Hi, and welcome to the videos for section 10.1. We're starting a new chapter here, chapter 10. Switching gears a little bit. So now we're going to be looking at systems of linear equations in 2 variables and 3 variables. We're going to be looking at how to solve problems with matrices. We're going to be looking at inverses. But in section 10.1, and this is the first of 3 videos. I don't remember if I had mentioned that, but first of 3. In section 10.1, we're looking at systems of linear equations in 2 variables. So we have a couple different ways of solving these. The first, we've actually already done it. When we were doing our mixture problems, we had x plus y is 100 gallons. We had the ratio of what the percentages were. And what did we do? We did the substitution method. So that's option 1. And the key for these is that it's linear equations, meaning we're just going to have a y to the first power and an x to the first power. And then substitution method, we're going to solve the equation for one of the variables, plug it into the other equation, and solve for the variables from there. So the steps, again, we're going to solve for one variable. It could be x, it could be y, depending on which is the easier way for us to go. It doesn't have to be y like we were doing in our mixture problems. We could solve it to say x is equal to something, and then plug that in for x. So we're going to solve for one of the variables. We're going to substitute that into the other equation. So now we have one equation with one unknown, so we're going to solve for that unknown variable. And once we have that, once we have y equals some value or x equals some value, we do what's called back substitute. So we go back to the other problem and we plug it in and solve for the other variable. So let's look at a quick example. Again, as I said, we've actually really done a ton of these already this semester. We had all those mixture problems where we were solving by substitution. So let's say we want to solve the system of linear equations. We have 2x plus y is equal to 1 and 3x plus 4y is equal to 14. So if this was the problem we were given, if it didn't tell us solve by substitution, by looking at this, well, we see that y is all by itself. So it's going to be the easiest thing to do is if I subtract 2x from both sides in that first equation, I get what? Y equals 1 minus 2x. And now that I have y by itself, I can substitute this into the other equation anywhere that I see y. So if I do that, what do I get? I get 3x plus 4 times y. Well, y is 1 minus 2x. And this all equals 14. So now I have one equation with one unknown, my variable x. And so I just solve for x at this point. So I get 3x, distribute the 4, so you get plus 4 and minus 8x equals 14. Subtract 4 from both sides. And on the left side I have what? 3x minus 8x, so that's minus 5x. Negative 4 from both sides gives me 10. So divide both sides by negative 5, I end up with x equals negative 2. So I've gotten to step 3. I've solved for one of the variables. I now need to back substitute so I can plug it into this equation here. I still need to figure out what's y. So I plug that into the equation that says y is equal to some value. So this is going to be what? 1 minus 2 times x, which is negative 2, so be careful with your signs. So this is 1, negative 2 times negative 2 is plus 4. 1 plus 4 is 5. So I get x is equal to -2, y is equal to 5. We could check our answers if we want, plug it into the other equation. We should get that they're equal. So you got -6 plus 20 is 14, so we can be pretty sure that the answer we got, x is -2, y equals 5, is the right solution. So that's it. Quick short video for video 1. This is talking about substitution. It's a technique we've been using all semester. Come on back and we're going to look at another option called elimination method, which if we don't have a variable by itself is oftentimes the easier way for us to go.